So the next topic in module 4 is modulation. Okay. So what is meant by modulation? Modulation can be defined as a process by which some characteristics of the carrier wave is varied in accordance with the modulating wave, right? So I can define modulation as process in which some characteristics of carrier wave is varied in accordance with the modulating signal. Modulating signal. So what is meant by this modulating signal? It is nothing but your message signal, okay, or information signal, or it can be called by another name, that is your baseband signal. So this is your definition of your modulation. So what may be these characteristics? It can be amplitude, frequency, phase, etc. So based on these characteristics, the modulation can be mainly classified into two different types, okay. So one is called as continuous wave modulation. Continuous wave modulation. Okay. And the second one is called as your pulse modulation. So this section consists of the overall idea of the continuous wave modulation and the pulse modulation. Okay. So continuous wave modulation can be classified into two types. One is called as amplitude modulation and the second one is called as angle modulation. Okay. Now this angle modulation can be divided into two types. One is called as frequency modulation and the second one is called as your phase modulation. Okay. So these are your different classification of your continuous wave modulation. Okay. Now moving on to your pulse modulation. It can be mainly classified into two types. One is called as digital modulation and the second one is called as analog modulation. Okay. Analog modulation. Now this digital modulation can be again divided into two types. One is called as pulse code modulation. The next one is called as delta modulation. Okay. Pulse code modulation. So PCM stands for pulse code modulation. Okay. And this analog modulation can be again classified into three types. One is called as pulse amplitude modulation. Then second one is called as PDM. So first one is called as PAM. Okay. Pulse duration modulation. So this is called as pulse duration modulation. And the last one is called as PPM. So PPM stands for pulse position modulation. Okay, position modulation. So these are the various classification of your continuous wave modulation and pulse modulation. Okay. Now, what is meant by continuous wave modulation? What is the difference between continuous wave modulation and pulse modulation? So, in the case of continuous wave modulation, both your baseband signal, that is your message signal, and your carrier signal are sine wave, sinusoidal in nature. Okay, both are sine wave, right? So for modulation, you know that there are two signals. One is your message signal, that is your low frequency signal, which is, let me take it as M of t or S of t. Okay, baseband signal, or it can be called message signal, information signal, which we have seen in the last part, right? So next one is your high frequency carrier signal. Let me take it as C of t. So this will be your both the signals. So in this case, both are sine waves in the case of continuous wave modulation. But whereas in the case of pulse modulation, your S of t or your message signal, you can take this as S of t or M of t. Okay, message signal is sinusoidal in nature, low frequency signal, but your carrier signal, in this case C of t, is a train of pulses. Okay, so this is the difference between your carrier signal. So carrier signal is sine wave in the case of continuous wave modulation, whereas in the case of pulse modulation, the carrier wave is a train of pulse, sequence of pulses. Okay, name itself gives you the meaning. Now you are going to study the overall concept of the different types of modulation techniques, mainly your analog and pulse modulation techniques. Okay, so moving on to your first type, that is called as amplitude modulation. So you know that modulation is the process in which some characteristics, so this some characteristics, I am going to replace it by either amplitude or frequency or phase. Then it gives you the definition of your particular modulation, amplitude modulation. So what is meant by amplitude modulation? So if I can make AM, FM and PM, three tables. Okay, so this will be your amplitude modulation, frequency modulation and phase modulation. So what can be called as your amplitude modulation? If the amplitude of the carrier signal is varied, amplitude of the carrier signal is varied in accordance with your message signal, then it is called as amplitude modulation. Similarly, what may be your frequency modulation? If the frequency of the carrier signal is varied in accordance with your instantaneous value of your message signal, varied with respect to your message signal, then it is called as frequency modulation. Similarly, what may be your phase modulation? If the phase of the carrier signal is varied in accordance with that of your message signal, is varied with respect to your message signal, then it is called as your phase modulation. So let us consider the first case, AM. So you know that the amplitude of the carrier signal is varied. So what are the two other factors which will be remaining as constant? So your frequency and phase will be constant in this case. Okay. Similarly, in the second case, in the case of frequency modulation, frequency of the carrier signal is varied. So that what are the two factors which will be constant? Amplitude and the phase of the carrier signal will be remaining as a constant value. Okay. Similarly, your phase modulation. In the case of phase modulation, what is the other two factors? Amplitude and your frequency will be remaining as constant in the case of your phase modulation. So this frequency modulation and phase modulation comes hand in hand. Okay, they are closely related to each other. So let us see what is meant by your amplitude modulation by means of diagram. Okay, so you know that you will be having two waveforms for modulation. One is your, what is your first signal? Let me write here, low frequency message signal. So if I take this as S of t, because in the first block diagram we have taken it as S of t, your baseband signal, right? So your low frequency, which consists of less number of cycles. So if this is your low frequency message signal, sinusoidal message signal, what is your second signal? Second signal will be your high frequency carrier signal. So this will be your low frequency message signal. Second will be your high frequency carrier signal. Okay, so high frequency carrier signal means your number of cycles will be more. Let me take this as C of t. Now your carrier signal will be very high frequency. Okay, so you will be having more number of cycles. So this will be your C of t. Okay, now what will be your structure of your amplitude modulated wave? So your amplitude modulated wave, so let me take it as x of t, right? X of t. So this will be your amplitude modulated wave. Okay, so your amplitude modulated wave will take the envelope of your message signal. So whenever you have the message signal to be high, your amplitude will be high. Whenever your message signal is low, your amplitude will be low. Okay, so this is how your amplitude modulated signal looks like. Okay, so this is going to be your amplitude modulated signal. Okay, so whenever your message signal is high, you will be having maximum amplitude. Whenever your message signal is less, you will be getting your minimum amplitude. So this will be your minimum amplitude and this will be your maximum amplitude. Okay, since the amplitude of the carrier signal in the case of modulated wave exactly replicates the modulating signal, so this is also called by another name. It is called as envelope. Okay, so the next type is going to be your frequency modulation. So as we have mentioned before, the frequency of the carrier wave is varied in accordance to that of your message signal. So if we draw the diagram, okay, so frequency will be varied. Okay, so the low frequency, first one is going to be your message signal, so which is a low frequency signal. Okay, and the next one is going to be your carrier signal C of t, which will be your high frequency signal. So this will be your carrier signal. So in this case, now what happens? Whenever the message signal is high, okay, so here the message signal is high, right? So whenever you have the message signal is high, you have the maximum number of cycles, okay, maximum frequency. And when you have the message signal is less, when the message signal is negative, you have minimum frequency. So this is how your signal goes. Again, you will be having here maximum. The frequency will be varied with respect to that of your message signal. Now the frequency will be carrying the message information of the message signal. Okay, so whenever the message signal is positive or whenever the message signal is maximum, you will be having maximum frequency, and whenever the message signal is negative, you will be having minimum frequency. Okay, so this will be your modulated signal. So this can be given as x of t. Okay, so this will be your message signal, carrier signal, and this will be your modulated signal. Okay, so this is called as frequency modulation. Now the original frequency of the carrier signal is called by the name center frequency. Okay, so center frequency, and it is designated as FC. So this will be your original carrier signal, Okay, so the amount by which the frequency of the carrier wave changes, okay, is termed as frequency deviation. So frequency deviation is given as del f, okay. So frequency deviation, the amount by which the frequency deviates, that is the carrier frequency deviates, is called as del f. So this del f is equal to constant kf into am, okay. So I can tell that this del f is directly proportional to the amplitude of the modulating signal m of t. So in this case m of t is nothing but s of t. So it is directly proportional to the amplitude of modulating signal, okay, modulating signal. There is one more factor that is termed as carrier saving, carrier saving, okay. So it is denoted as CS. CS is given by 2 into frequency deviation. So carrier saving, so this is called as carrier saving, 2 into del f. The last one is your modulation index. Modulation index. Modulation index is defined as the ratio of the, it is given as mu f, okay, mu suffix f. It is given as the ratio of frequency deviation, that is del f divided by modulating frequency, modulating frequency. So del f is equal to, I can write here, del f is equal to, sorry, mu f is equal to del f divided by fm, modulation index, okay. Mu f is equal to del f divided by fm. So this will be your modulation index of your frequency modulation. Now the last one is going to be your phase modulation. So what is meant by phase modulation? The phase of the carrier signal will vary, whereas your amplitude and the frequency will be kept constant, okay. So in the case of phase modulation, it is also another form of angle modulation. Both these comes hand in hand, right? So if I take this as your modulating signal s of t, which is a low frequency signal, so this is your t, this is your carrier signal c of t, which will be having a high frequency signal, okay. Now how will you get your phase modulated signal? So in the case of phase modulated signal, as the modulating signal increases in the amplitude, what happens to your phase of the carrier signal? There will be a phase lag, okay. So now here there will be phase lag, so it will be stretched off, okay, during the positive half cycle of your message signal. Whereas in the case of negative half cycle of your message signal, there will be a phase lead, so the signal will get compressed, okay. So again, during the positive there will be a phase lag, and during the negative there will be a phase lead, okay. So here there will be a phase lead. This is how you will be getting your phase modulated signal, okay. Phase modulated, it is closely related to your frequency modulated signal. So the next topic is going to be your 3 types of your pulse modulation, okay. Pulse analog modulation. So in this case you have, what are the 3 types? You have PAM, pulse amplitude modulation, pulse duration modulation, and PPM, pulse position modulation. So what is the only difference which you have in your pulse amplitude modulation? You have your same message signal m of t, or I can take it as s of t, low frequency message signal. What will be your second signal? The carrier. So in this case I have told the carrier is nothing but a train of pulses, okay. So c of t will be different here. So this will be train of pulses, and it is periodic in nature, okay, equally spaced. So periodic carrier signal, high frequency carrier signal, that is a train of pulses. So what will happen to your PAM? PAM will be whenever your message signal is maximum, it will take a maximum amplitude, just similar to that of the previous case. And whenever the message signal is negative, you will be having minimum amplitude. Okay. The only difference is now you will be having instead of the envelope, you will be having the pulses, same pulses of your carrier wave. Okay, you can make this point flat by using another one circuit that is called as your sample and hold circuit. So this is the direct waveform without your sample and hold circuit. So this will be your modulated wave, x of t, PAM, pulse modulated wave. Okay, pulse amplitude modulation. So this will be your pulse amplitude modulated wave, where whenever the message signal is positive, you will be having maximum amplitude, and whenever the message signal is negative, you will be having minimum amplitude. Okay, so this is called as your pulse amplitude modulation. Next one is your pulse duration modulation. This pulse duration modulation is also called by another name, pulse width modulation. So I forgot to tell one thing, pulse amplitude modulation means the amplitude of the pulse will be varied. Amplitude of pulse will be varied in accordance with your message signal. And what will be kept as constant? The width and the position will be kept as constant. Okay. So pulse amplitude modulation. Pulse width modulation means the width of the pulse will be varied. Width of the pulse will be varied. In accordance with that of your message signal, with respect to your message signal. So what will be your waveform? How will you get your waveform? So if I take this as your message signal, low frequency message signal, S of t. What is your carrier signal? Carrier signal will be your train of pulses with constant width and periodic in nature. Okay, so this is going to be your C of t. Now what happens in your pulse width modulation? Whenever the message signal is positive, the width of the pulse increases. Whenever the message signal is negative, you will be getting minimum width. Okay, so here you will be getting the maximum width. Now width will be varying, so you will be getting maximum width. Okay, so whenever the width is message signal is negative, you will be getting minimum width. So this is how, again here it is positive, right? So you will be getting width will be increasing. Now you will be getting maximum. Now whenever the message signal is negative, you will be getting minimum width. So here you will be getting maximum width, and whenever the message signal is negative, you will be getting minimum width. Okay. So this is nothing but your x of t, pulse width modulated wave. So this will be your waveform. Okay, so this is t, pulse width modulated wave. This is your carrier wave, and this is your message signal. Okay, now the pulse position modulation can be obtained from the pulse width modulation, whereas the position of the pulse will be varying. So x of t, if I take this as pulse position modulation, the position of the pulse will be varying, but what will remain as constant? Position of the pulse varies, but width and amplitude remains constant. Okay, so what will be your value now? So at the instant of whenever you have this pulse width modulation, you can use triggering, okay, negative edge trigger. So whenever you have a negative edge here, so during the negative edge of the pulse width modulated wave, you will be having your pulse position modulation with constant amplitude and constant width. Now the position will be varying, but the width remains constant. So this is how you can generate the pulse position modulated signal from the pulse width modulated signal. So here again the negative triggering, negative falling edge of your pulse width modulated wave, you will be getting your ppm, okay, pulse position. So all these different types of modulation is used for particular applications, okay. So these are the different types of modulation techniques, whereas the next digital type of your pulse modulation, that is your pulse code modulation and delta modulation, will be converting the signal into coded form, okay. Modulated signal will be in the form of coded data. That is the only difference. So this are the topics which is involved in your syllabus, okay. So the notes will be available on my Telegram channel. The link will be given in the description box, okay.